Welcome to my video on division properties of square roots. In this video, I'm going to look at this relationship right here where the square root of a divided by b is just equal to the square root of a divided by the square root of b. But we have some limitations here. A has got to be a non-negative number, and b has got to be greater than 0, because if you divide by 0, things blow up. We don't want to divide by 0. Let's look at an example. Let's take square root of 36 divided by 49. Now using this rule here, that's square root of 36 divided by the square root of 49. Square root of 36 is 6. The square root of 9 is 7. So that's our answer. 6 over 7. It's a fraction. Let's do another example. Square root of 25 divided by 64. Square root of 25 divided by the square root of 64. Square root of 25 is 5. Square root of 64 is 8. So it's 5 over 8 is our answer. And what we need to note here is we need to note both numerator and the denominator are perfect squares. So I picked the simplest case here just to show this to you. Believe me, this is not going to be the only type of radicals you're going to see. So let's mix it up a little bit. So let's find exact square roots involving fractions. Okay. 9 divided by 64 times 64 divided by 400. Now you can see we've got some perfect squares in here, but we're going to be multiplying these, so it's going to be a little different. So dividing this all up, it's the square root of 9 divided by the square root of 64 times the square root of 64 divided by the square root of 400. Now these are going to go away. The 64s are going to divide out. So we're going to be left with the square root of 9 divided by the square root of 400. The square root of 9 is 3, and 20 times 20 is 400. So we're going to get 3 divided by 20 is the answer here. To simplify the square root of a fraction whose denominator is not a perfect square, so we're dealing with the case not a perfect square. We've been looking at perfect squares. Change the fraction to an equivalent fraction which has a denominator that is the smallest perfect square. So we're going to make it into a perfect square just by doing some multiplication, and then that will make the problem a little simpler to solve. So let's look at the square root of 1 over 8. Well, 8 is not a perfect square, but if we multiply both the numerator and denominator by 2, we get 2 times 1, 2 times 8. That's equal to the square root of 2 divided by 16. Now we can break that up using our multiplication division law. Square root of 2 divided by square root of 16 is equal to root 2 divided by 4, or 1/4 of the square root of 2. So there we turned a non-perfect square root into a perfect square root just by some multiplication. Now that's simplifying square roots of fractions whose denominators are perfect square roots. And we're going to get back to the square root case. Now in this case it's going to be the denominator is a perfect square root. Let's look at the example. X times the square root of 200 divided by x squared. So there the denominator in the radical is a square root, perfect square root, because x squared is a perfect square root. So we can rewrite this. X times the square root of 200 divided by the square root of x squared. That's going to be x times root 200 divided by, then the square root of x squared is just x. These terms go away. So now we're going to be left with just the square root of 200, which is going to be equal to, we can factor out the 100, square root of 2, square root of 100 is 10, so we've got 10 root 2. That's the simplest form we can break it down into. So these two are equivalent expressions because the x's go away. Now let's look at simplifying square roots of fractions whose denominators are not perfect squares. So let's look at this example here where we've got same type of procedure. We're going to turn it into a perfect square. 3 over q. Now we multiply inside the radical by q on the top numerator and denominator. 3 times q, q times q. So that's equal to the square root of 3q divided by q squared. Now we can break that up using our fraction of radicals. And we're going to get 3q divided by the square root of q squared. And that is just going to be equal to the root of 3q, because the square root of q squared is q. So that's going to be our answer in simplest form. Well, I hope you got something out of this video, learned a little bit about square roots and quotients. If you did, give me a like, a thumbs up, subscribe to my channel. Thank you for watching.